Okay, so we're going to try to get through this. If we may not get all the way through. There's extra time built into the class though, because our last 2 days we spend a lot of time focusing on the main projects. So if we need to, we'll shift things a little bit. Okay, so we've talked a little bit about vectors, and these are our one-dimensional type of data class. And there's a bunch of different types of data within those. We can have characters, which we talked about, which are basically like alphabetical, or as we saw, it can be numeric when we had our column names that were years in our data in the lecture that we just did with Ava. And so when we have characters, we need to use quotes to tell R that we want it to be considered a character. Numeric is any sort of real number, and there's a couple of different types, and we'll talk about that, including integer and something called double. We have factors, which are categorical strings, and then we have logical, which is either true or false, and a couple of data types for dates and time. So we're going to go through these a little bit. Okay, so a little bit of detail about numeric and character classes. We talked about this on the first day, but if you have, strings with our quotes, we're going to end up with a character vector. And if we have numeric values like this, it'll be numeric when we check it with the class function. But this can get a little bit tricky. So if we combine, which we did do an exercise like this in our first lab, if we combine numeric values with character values, character will always trump. And so the vector becomes character class. And we can also make numeric values become character by using quotes, like we saw with our year data. So there are two types of numeric subclasses, integer and double. Integer basically means a whole number. And so anytime we do something like this, where we list them with the combine function, we'll see that the class is numeric, but the type of will show us that it's double. So basically the type of function gives us a little more detail. So double instead stands for double precision, and that's going to give us fractional values instead of whole numbers. So for example, was there a question? Thought I heard something. For example, if we typed out a vector where we have decimal places for some of our values and we check the class, it'll again be numeric, but the type of will be double. And so tibbles are really great because they automatically show us what class and what type of values we have in our data. And so here we're using some vectors to create a tibble, and the vectors that we just use actually to show our examples. And we're naming them these names for their columns. And we see that here it shows that they're both double because tibbles generally keep numeric values as double. So that's what the DBL stands here. And if we had a character vector, it would say, I think CHR. Logical variables are a special type, which we briefly showed a little bit about. And so they have to have a value of true or false. This can be really helpful for certain statistical analyses. It's important for this to actually work that you don't include quotes around true or false. Otherwise, you can see when we don't include it, it becomes class logical. If we do include quotes, then it's considered a character. So kind of like you might expect, because anytime we use quotes, R thinks that it's a character. So there are a couple of functions that can help us to both check and also change our class. So this class name part here can be changed out for whatever class we might be checking. So it could be, for example, is character, or we could coerce something with as character to become a class that's character. So we'll show some examples. So for example, here we have a numeric vector. And if we were to just check it here by itself, it would say is true, that it is numeric. If we ask, is it a character? It says, no, it's not a character. And here where we have things in quotes, we check, is it a character? And the answer is true. And of course, it is not numeric. So the answer is false. All right. And so sometimes when you coerce or change your class, it works really well. So say we want to change our numeric vector of 147 to character, we use as character. And we can see that the output happens really nicely. Or if we want to take that vector and move that back to numeric, we can use as numeric. And again, this works really easily. Similarly, if we have characters of true and false, which often happens when we read in data, and then we want that, we need to check that our variables are what we would like them to be. And so if we want our variable to be logical, we can say as logical. And indeed, this changes easily. And then here we can do as integer to change something that has fractional values to be a whole number. But for whole numbers that we can also make them as double. It doesn't change the value here because it's really essentially 3.00, for example. But sometimes this doesn't work as well as we'd like. And when that happens, we'll get an NA value or not available. So for example, here we have a 1, a 4, and a 7A, and we want to make that numeric. So 1 and 4 will easily be converted, but 7A, because it has a character, cannot be easily converted to be numeric. And so we get an NA value. Similarly, if we have something else, this is really common in data to have different values for NA. And so if we have unknown or other codings for something, for our logical variable, it will become NA. And also with date values, if the date isn't set up correctly, or it's not possible, like there aren't 32 days, then we'll get an NA value. Factors we'll be talking about in depth later, but just so you're aware, factors are a special type of character, but that has levels. So for example, maybe you're comparing something that has small, medium, and large. We would probably want to think of these as having an intrinsic value, where small is less than medium and medium is less than large. And so we would want to make that a factor, and we can use the factor function. So in the other cases, we're using as dot in the class name, but here we're just using factor. It's one variation. Note that, so here when we look at the class here, we see that it's now been changed to factor when it was previously character. And when we take a look at our new factor vector, we see that it lists levels here. And in this case, it's using large first, then medium, then small. And that's because it's doing it by alphanumerical order. So that's probably not what we want. And we'll have a lecture where we focus on factors and show how to change that. If you want to just check your levels, though, you can use the levels function. So you can also convert these with as character and as numeric. Okay, and then we're going to cover just briefly how to make variables or vectors. And so one way that we can do, which was briefly covered for some other things, is the repeat function. So REP stands for repeat. And so say we wanted to make something that repeated multiple times, or where each item was repeated a number of times, this function is really helpful. So there's an each argument and a times argument. And it's kind of helpful, I think, just to look at the examples to understand what they mean. So for example, here we have a string where we have the word black and the word white, and we want to have each of them repeated 3 times. So that means that black will be repeated first 3 times, and then white will be repeated. But if we use the times argument instead of each, then we'll get this whole vector repeated 3 times. And you can combine these and do both at the same time. So here we have black repeated twice, white repeated twice, and we have this whole thing repeated twice. Okay, and then there's our seek function, which can be helpful for creating our numeric values. And it can help us to make both integer and double, which again is our fractional values, numbers with decimals. And it just depends on how we specify it. So there's several arguments that we can use. There's the from argument, which tells us what number to start on. The to argument, which says what number to go up to and not go above. The by argument, which is basically how we want to step between the to and the from. And if we don't use the by argument, we can use the length argument, which shows us, or will specify how many different values we want. Again, don't use by and length out together. So here we can see, I mean, you can try it, but you'll get an error, is what I mean. It's not like it's just bad practice or something, it's just that it'll cause an error. So here we have, it's possible that I guess you could do by and length out in the perfect way so that you know that you're going to get the right number of values, but it's unlikely. So here we're showing some examples. We're going from 0 to 1, and we want to step by 0.2. So we can see that we step by 0.2, 0.4, 0.6, etc. Or if we want, so this gives us a double vector. If we want an integer vector, we would say by 1. And here we're getting a double vector. We're just asking for 10 equal numbers between -5 and 5. Equal steps, I mean. And so then there's also a sample function, which helps us to create vectors that are a random sequence of numbers. And to create these, we need to use something to sample from. So you can think of the sample meaning we're taking a sample, a random sample from something. And so we have an X argument that specifies what exactly we're sampling from. We have a size argument that specifies how many values we want, and a replace argument that specifies if we want to replace values or not. So we'll go through those a little bit. So first, we're going to create something to sample from, and we're going to use the seek function. So we have from 0 to 100, and we're making this integers, so it's whole numbers. So we're doing it by 1. And so we get from 0 to 100 here, as we see. And now we want to take a random sample using the sample function from our seek_hun object, and we're going to have it be 5 numbers long. And we say replace equals true, which means that if it wants to, it could randomly do 82 twice. In this case, it just randomly didn't replace anything, but if it wanted to, it could. If you don't want to replace, you can do replace equals false. So in summary, there's two types of numeric class in objects, which is integer and double. Our logic class is true or false without quotes. Make sure you don't use the quotes, otherwise it will be character. There's the is class name function where we replace class name with whatever class name we want to look at to test if an object is that particular class. Or we can use as class name to change the class of the object. So for example, as character. We'll be talking a lot more about factors. So don't worry too much about that now, but they're a special type of character class. The repeat, seek, and sample functions help us to create new vectors. Repeat repeats things. Seek makes numeric vectors, and sample makes a random vector from some other vector or object. And importantly, tables can show what our column classes are. So with that, we'll go to our lab. Okay, there were some requests to go over some things based on our feedback. So I'm gonna just review a couple of topics really quick. So I'm gonna share my RStudio. Well, we have some other people coming on. So there was a question about the mutate function, which I know is a really tricky one at first to kind of get the syntax in order. So basically, our mutate function helps us to either create new variables or modify existing ones. And so, for example, we might do something like this, where we have our empty cars data and we want to change the miles per gallon to be 100 times what it used to be. So in this case, we're modifying the existing MPG to be 100 times what it is now. Or we can create a new variable by naming it something different. So if we name it something different, when we look at empty cars, because I'm not reassigning this, I'm just printing it to the console, I'll see here's my original MPG value. And now there's this new variable called MPG new. But if I just want to modify the existing one, I would leave the name to be the same as the existing variable. And now we see that there isn't a different variable added. We've just modified the existing MPG variable because it used to be like in the 10s and 20s, and now it's in the thousands. Just gonna check the chat here.
It's just a question about when we don't have class. So no class on Monday.
Yeah, we'll announce that later too, because that's important. And then another question was about the tidyverse. And so when we load the tidyverse, it's like loading a mega package that has all these other packages inside of it. And so we're loading dplyr, we're loading tidyr, we're loading readr. So it's just a really awesome way to not have to load individual packages. We can just say library tidyverse and everything comes if we've installed it. And so inside tidyverse is where we have these packages that have been developed by people at RStudio and elsewhere, but mostly RStudio. And they're designed to be especially intuitive and to talk to one another, because previously most packages, and this continues to be true, are just developed by all kinds of different people and they don't necessarily talk to one another well. And so this is nice because they have a common structure. Yeah. And Ava's put the link in the chat so you can look up more information. Okay, so we're going to start with our data classes because we have a little bit more to cover on that. So I'm going to pull up the slides so I can just share my So I'm back to the schedule here on the website, and I'm pulling up the slides here, and we're going to go all the way to two-dimensional data classes. So it should be the first slide after the first lab, because we finished with the first lab yesterday. So I'll give you a minute to get to that slide, because it might take you a bit if you're taking notes or something. Okay, so we've talked about vectors. Yesterday we talked a lot about vectors, which are one-dimensional data classes, and we're going to talk about some additional two-dimensional data classes now. So there's our data frame and our tibbles, which we, of course, have discussed already, and those are extremely useful and probably what you'll be using the most. But there's also some others, like a matrix, which is essentially like a data frame or tibble, but every single entry is either all numeric or all character. So it has to be all the same data class for a matrix. And so to create a matrix, there's a couple of functions that we can use. There's the as.matrix, which is to coerce a data frame into a matrix, or you can use matrix to create a matrix from scratch. So for example, here, there's an iris data set about flowers that comes with base R. So if you just type in iris in your console, you'll see this data. So here we're just looking at the first 6 rows. And this has mostly numeric data, but there's a variable called species that is character. So if we remove this species variable by selecting it out with select and the minus sign, then we can create a matrix out of that because it's all numeric. Another type of variable is, or three-dimensional data set, is a list. And a list is really cool because it can allow you to hold lots of other types of data. And so it can hold vectors, it can hold strings, it can hold matrices, models, data frames, all sorts of things. It's particularly useful if you're doing some sort of iterative work. Usually it would probably be working on a list of multiple data frames. But you can also even have lists of other lists, which would sort of be like a 3D data set. I saw that in the chat. So here we are. I'm going to make a pretty simple list. We're going to use a vector that we're making here out of these characters, and a numeric vector here, 1, 2, 3, and a matrix. And here we're making a matrix from scratch. So you don't need to know too much probably about making these from scratch, but say you want it to have 2 columns and 2 rows, and you want it to go from 1 to 4. So this is what you'll make the matrix out of. And then you basically just say how many columns you want. And so here we see our ABC vector, or 1, 2, 3 vector. And here we see our matrix, which has 2 columns and 4 values. And so here we've combined in our list all of the elements, and we can see that we can kind of, there's a numeric value for each of these so that we can find the different sections. You can also name each of the different sections so that it's easier to figure out where each piece is. So you could name the first one to be letters by using letters equals inside the list function, numbers equals for the numeric vector and a matrix for the matrix. And so this is our output here with the names. So this could be helpful if, again, if you have lots of data frames, and you could name each of your data frames for different years. For example, if you had a survey and you had data from different years that you wanted to compare. Although honestly, I generally just make even larger data frames, and Ava's going to talk later about how we would join and merge data frames together if that was something you wanted to do. Yeah, so we're not going to go greatly into this. We just wanted to give you an understanding of some things that you might encounter when you're talking to other people about R. So some people who use base R use a lot of lists. Okay, and then we're just going to cover really briefly about a couple of special data classes that, depending on your work, you might encounter. So these are dates and POSIX CT classes. And so if you work with dates or times, then these might be useful for you. So the date class represents calendar dates, and the POSIX CT class represents calendar dates, but also hours, minutes, and seconds. And so we can convert data from character to these classes so that we can use special functions that are intended for this type of class, so that we can compare a range of dates, for example, or something like that, which we'll show in a second. So we'll make it a little more clear. So these come from the lubridate package, which is really powerful for working with this type of data. And correct me if I'm wrong, Ava, I don't think it's in the, when you load tidyverse, I can't remember. I always have to look it up. Because there's packages that are what they call tidyverse adjacent, which are packages that may or may not get used super commonly, but need to be loaded separately. I think it is actually in the tidyverse though when you load it, but Ava will confirm that. So here's an example. So let's say that we have a date here, and so it's from the year 2021, and it's June 15th. And if we look at the class for this, R is not automatically going to realize that this is a date. So it just thinks that this is a character vector. But if we use the lubridate package, and we can always make sure that we've installed it by separately installing it and do library lubridate. There's a really great function called year, month, day, YMD, that we can use on such types of dates, because here we have our year, our month, and a day. And so now when we look at the class of this vector, it says date. We could also use the date function, but I would suggest that you try to use the more specific functions, because sometimes your date will be formatted in a way that it needs lubridate to recognize. Okay, yeah, so it's tidyverse adjacent, which I guess is why I had these quotes. So it's like the tidyverse family because it's created with a similar structure so that it talks well with these other packages, but it's technically not part of the core tidyverse when you load library tidyverse. Okay, skipped an R there. Okay, so the great thing about this though is once you convert your data into this special type of date class, then you can do really nifty things like this. So here we have a date A, which is June 15th from 2021, and a date B, which is June 18th. And we can actually subtract these and get an output that says the time differences of -3 days. So that's really helpful if you want to know how many days it's been between something that's challenging to figure out. So again, the date function is kind of picky, which is why I suggest you go with the more specific functions that are within LuberDate. So, this worked for us. This also works for us, but here we could use something like month, day, year if our data is set up differently. So previously we had our data with our year first, our month second, and our day last. And so we would use year, month, day, YMD. And here we have our month first, our day second, and our year last. So using the month, day, year would be a good idea. And then there's our POSIX CT class, which is the class that has information about time as well as date. And so similarly, if we just type in a date with a timestamp, it's going to first be seen as character by R. But the LuberDate package has fancier functions like year, month, date, _, hour, minutes, seconds, that we can use to convert this into a POSIX CT type of data where we have it recognized for both date and time. So here we can see that the class has changed. So by default, it uses the universal time zone in case you need to work with different time zones. Nice to keep that in mind. But there's other functions too, like say you only have hours and minutes, you don't have seconds, or you only have hours. There are other functions for that. If you're using a lot of data, I highly suggest checking out the LuberDate package more in depth, because this isn't necessarily a type of data that everyone would be using in the class. We're just sort of skimming the surface here. So in summary, we have two-dimensional data objects such as data frames, tables, matrices, and lists. A matrix is basically the same as a data frame or table, and that it has columns and rows, but the difference is that all of the data is of the same data class. We can create a matrix from scratch using the matrix function. You just specify numbers that you're going to use, like maybe seek, using the seek function, and the number of columns, and that's to make it from scratch. Or you can convert a data frame to be a matrix using the as matrix function. Just remember that you need all of the variables to be of the same class. If you want to combine multiple types of data together, you can use the list function. They can be the same type of class or they can be different. So it can be multiple data frames, or it can be data frames and vectors and matrices, or even lists of lists. And the LuberDate package is super helpful for using date data. We generally suggest that you use the more specific packages if you're going to do that. And it's also helpful for looking at times as well. All right. So with that, we can jump into our lab if there's not any questions.
I actually have a question.
Oh,
Oh, so we got a good question in the chat about sometimes when you install packages are asks to restart or refresh. Do you know if there's, because I don't know the answer, if there's any kind of pattern for that. I just noticed sometimes that happens, sometimes that doesn't. I don't know if you know, Carrie, if there's any like reason why sometimes that happens and sometimes it doesn't.
yeah, it gives a message about it that's something to do with like, I think it's when, it might be when there's certain function names that overlap or something. And so it wants to refresh those. But yeah, I'm not really sure. It's like, it's something that I kind of take for granted, that I'm just like, okay, restart.
Yep, it's not gonna, hopefully not gonna interfere with anything. Just sometimes you have to click, okay, yep.
Yeah, this is a more advanced topic, which is why we're just glossing over it. But in case you ever need to do something iteratively or across multiple data, like perhaps you have, for example, multiple data frames for maybe a survey, you have multiple different years or something, and you're importing it, and you haven't quite gotten to the point of putting them into a nice data frame because they can't be coerced yet to be joined because they're not the same size or something like that, then it could be helpful to put them together so that you can do certain things on them iteratively. And we'll talk more about iterations later, but basically what we mean is we want to do something to each piece of the list. And matrices are mostly used for linear algebra, certain types of math. So there are certain analyses that might require you to use a matrix. And in that case, then it's helpful to know how to make one. And generally, you wouldn't make one from scratch, which is why I barely covered that one, but you would typically coerce a different data frame into a matrix using the as matrix function. So that's just specifying what values we want in our matrix and how we want them to, and then the number of columns says how we want them distributed. So here we have 1, 2, 3, and 4. So this is 1 to 4. And we're going to have 2 columns. All right, so you might come up with a situation where you've imported your data frames and they can't be put yet together into a giant tabular data frame. And so in this case, you might need to use lists in the initial steps of wrangling. But ultimately, yes, I think it would be better to use a tibble or a data frame. You can't use a lot of the tidyverse functions on some of these 2D or 3D data that aren't tibble or data frame. So just in case you encounter a situation where someone's using them, now you know what they are. All right, so we're gonna go to our lab. I'm just gonna grab the link here and put it in the chat for people.